Hi, I'm Brenda, BSIT student, and I'm gonna show you my laboratory about kinetics and chemical equilibrium. So now we have the two experimental setup about here. So we have the brass in boiling acid solution for graph A. So this is the graph for graph A. And graph B, brass in boiling basic solution for graph B. So, first question, identical pieces of brass were placed in two different boiling liquids for 12 hours. The graph shows how the mass of each piece of brass changes. And letter A, give one similarity in the change in mass of the brass in both liquids. So, the density of the brass when it comes to the boiling acid solution and when in boiling basic solution. So the similarity between both graphs are that the rate and initial point are constant. Because for the both graphs, the initial rate has constant slope. So the ratio of mass loss and time remains constant for both graphs. As the graph is linear at initial point. So we're going to letter B. Describe two ways in which the loss of mass shown in graph A is different from that shown. For my answer, the brass has a greater density than boiling acid solution, whereas the same brass has a lower density than the basic boiling solution. So we're going to C. List 3 different safety precautions that are needed in doing this investigation. Answer. First, usually there are approved safety goggles or eyeglass that are worn while working in the lab. These safety glasses protect anything from entering your eyes. Second, always ensure that you wear proper fixing clothes and nothing that is too loose. You should also wear your lab coat to avoid spilling anything on your clothes. And third, one must also know how to use the lab equipment properly and should ask the right way to use it in case they do not know. So now we're going to the next exercise. The rate of reaction between hydrochloric acid and aqueous sodium thiosulfate was investigated. So, 5 tests were done using the tools shown below. So, this is my tools that I'm gonna show you. The 500 cubic centimeter conical flask, hydrochloric acid, sodium thiosulfate, and a sheet of paper or printed sheet of paper. We have the distilled water. So, because I don't have any graduated cylinder, so I'm going to show you about this. This is the measuring for my experiment. In test 1, using a graduated cylinder, 60 squared of aqueous sodium thiosulfate was poured into a conical flask. The conical flask was placed on a printed sheet of paper. 10 cubic centimeter of hydrochloric acid was added to the solution in a conical flask and stop the clock started. So now, this is so have to put 60 square centimeter in thiosulfate. Then was poured in conical flask. So this is my the conical flask was placed in a printed sheet of paper. Then 10 centimeter of the hydrochloric acid was added to the solution. So I have to do this. The conical flask was placed in a printed sheet of paper. 10 centimeter of hydrochloric acid was added to the solution in the conical flask, and stop the clock started. The reaction between the aqueous sodium thiosulfate and hydrochloric acid is like cloudy. So the answer, the reaction when sodium thiosulfate is added to a solution of hydrochloric acid is an insoluble precipitate of sulfur and is formed. This happens because of the precipitate of elements sulfur that are being formed, which are insoluble and eventually cloud the water. It's cloud. So the time. So we're going to test it. Using a graduated cylinder, 50 cubic centimeter of aqueous sodium thiosulfate was poured into a conical flask, followed by distilled water. So giving the thiosulfate. Followed by distilled water. The conical flask was placed on a printed sheet of paper. 10 cubic centimeter of hydrochloric acid was added to the solution in conical flask and stop the clock. So we're going to test 3. Test 2 was replicated using 45 centimeter of aqueous sodium thiosulfate and 25 cubic centimeter of distilled water. aqueous thiosulfate. This is thiosulfate. 45 centimeter. 25 distilled water. And test 2 was replicated using 35 cubic centimeter of aqueous sodium thiosulfate and 15 centimeter of distilled water. Distilled water. So this is it happens. The aqueous sodium thiosulfate and distilled water. So we're going to test 5. Test 2 was replicated using 10 cubic centimeter of aqueous sodium thiosulfate and 20 cubic centimeter of distilled water. 10 centimeter. And 20 cubic centimeter of distilled water. 20. And now, that's my end of my activity. Thank you for watching.